Hello everyone, myself Adarsh, student of Creodimal College, is going to present the presentation on solid phase synthesis, Zwitterand and pK value. What is solid phase synthesis? Solid phase synthesis is heterogeneous reaction in which a reagent is coupled to a solid support via chemical functionality present on solid support. A multi-step synthesis on solid phase then transfers the bond intermediate into the target molecule but eventually cleaved from support. This technique is also known as solid phase synthesis. Solid phase synthesis was invented by Bruce Merrifield in 1963. It is basically synthesized by condensation reaction of carboxylic group of one amino acid and amino group of second amino acid. Component of solid phase synthesis. These are the components of solid phase synthesis. First, resin, which is also known as solid support. These are inert polymer beads, often polystyrene or polyacrylamide, designed to soil in specific solvent. They provide a stable anchor for the growing molecule, allowing for efficient reaction and easy separation. Second, linkers, specialized chemical group that bridge the gap between the resin and initial reactant molecule. They are engineered to be stable during synthesis but readily cleavable under specific condition to release the final product. Third, protecting group, temporary chemical modification applied to reactive functional group like amino or carboxylic to prevent them from particular participating in undesired reaction during the multi-step synthesis process. They are removed at specific stages without affecting the desired product. How does it work? These are the four steps in which they are worked. First is initiation, resin attachment. The first protected building block, such as an amino acid, is covalently attached to the insoluble solid resin, serving as the foundation for the growing molecule. Second, deprotection or coupling reaction. Deprotection, the reactive group on the attached molecule is selectively deprotected. Coupling, the next protecting building group is added and reacts with the deprotected side. Washing, excess reagents and byproducts are thoroughly washed away, simplifying purification. Third, repetition for chain elongation. The deep protection and coupling cycling is repeated until the entire molecule chain, such as peptide or oligonucleotide, is completely assembled on the solid support. Cleavage and final product. Once the synthesis is completed, the desired product is chemically cleaved from the resin. Protecting group like VOC, tert-butyl oxycarbonyl ensure selective reaction throughout the process. Zwittern. What is Zwittern? It is a fascinating molecule that carries both positive and negative charge, yet maintains an overall neutral charge. This internal charge separation is crucial characteristics for many biological molecules. Amino acid. It is the prime example of Zwittern. In solid state, amino acid exists as dipolar ions called Zwitterine. While discussing whether a substance is Zwitterine or not, the pH range in which the information required must be specified. Structure of Zwitterine at physiological pH around 7.5, the amino group NH2 is protonated to NO3 plus, while the carboxylic group COH is deprotonated to COO minus. These opposing charge result in a net charge of zero. This is the structure of Zwitterine. pK value. Each ionizable group has a specific pK value, which is the pH at the which half of the molecules are in the protonated form and half are in the deprotonated form. It measures the acid strength. If it has lower pK value, then it is stronger acid. It is have higher pK value, then it is weaker acid. If pH is lesser than pK, then group is protonated. If pH is more than pK, then group is deprotonated. pK value helps in predict the form of amino acid at any pH. pK in amino acid have two main group, COH group and NH3 group. First pK 1 carboxylic group COOH. pK is nearly 2.2, which ranges from 1.8 to 2.5. This group is acidic and loses H plus first when pH increases. At pH more than pK value 1 becomes CO minus. At pK2 amino group NH3 plus, pK is nearly 9.0 to 10.5. This group is basic and loses its proton at higher pH. At pH is more than pK2, then become NH2. This is the amino acid. Thank you and have a nice day.